All right, so what you know about this problem is you know the string has a length L, you're given an angle theta, and this has some charge Q, and it has some charge M. And the mass and the charge on these two are the same. And because they're both positively charged, they fly apart and they come to rest at this point. So the way to solve this problem is to consider the charge on the right-hand side, for example, and look at the forces that are acting on it. So the first force is gravity, which pulls down with a force of mg. There is a tension, which is pulling in this direction, and if you work out the geometry, this is the angle theta right here, so that's the tension T. And then there's an electric repulsive force that way, which is the electric force. So the thing to do is, because this is in static equilibrium, is to add up the forces in the y direction and set them equal to 0. So in the positive y direction, you're going to have a component of t going up minus mg going down, and that's going to equal 0. And so that is going to allow you to find the tension T. Okay? So that's the first step. The second step is you're going to have to add up the forces horizontally. They also have to equal 0 because this is not moving. It's in static equilibrium. So once you know T, then in the horizontal direction, the force to the right, which is the electric force, minus the component of T going to the left, have got to add up to 0. And that's going to allow you to find the electric force, since you already found the tension in step 1. Once you know the electric force, you can figure out the charge, because you know the electric force, which you found, so this is step 3, must equal K Q1 times Q2, so that's Q squared, divided by the distance between them squared. So if you can work out this distance, so you know the length of the hypotenuse, you know the angle, you can find this distance right here, and of course the distance between the charges is twice that distance, because this is a right angle. Then you know the electric force from step 2. You know K because it's a constant. You know the distance between them in meters. You can solve for Q. And so there you go. You can find the electric charge Q on one of the two charges. And since they're identical, you know both of them in that case.